Welcome to the Frontier Space Podcast, a series about the environment, engineering, and health on Earth, in space, and beyond, with your host, Cole Lutz. Dr. Leslie Field, welcome to the Frontier Space Podcast.
Thank you so much for having me here, Cole. I'm really interested to hear what your podcast is all about and to let you know about our work.
We had to share your important research and work here, and uh, would love to hear more about what really inspired you toward this research to preserve ice.
It's like, oh heavens, what could I do about that? And I had been taught by a great mentor at one of my jobs, Hewlett Packard Labs, that if not me, who? If not now, when? That's a beautiful quote from way, way back. And it's so true. And it's like, well, okay, what could I, as one person out of billions, do about this?
And I think it's like really a function of asking ourselves each day, hey, how much dying marine life and animals do we continue to, damage and then feeling those emotions and feeling their emotions and the coral and all the ecosystems.
Yeah, I think most of us who are doing this kind of work, you know, really diligently, really full out, are doing it out of love for what we've got here and what we can't afford to lose, right? Because but the loss of the biodiversity on the planet that has been sustaining us all this time. And I asked myself a really simple question finally. It's like, I wonder if there's some bright, reflective, safe material that we could locally put on top of ice so that we could see if there were any, unintended consequences there, that we could put on top of ice and make the ice last longer. And that's been the thread of my work ever since then. Started out focused on sea ice, have switched now because it's hard to get permissions to do field testing on sea ice, and it's hard to learn what you're doing, really, to actually figure out how well it works in real conditions if you don't have the permissions to work in those areas. And I would never work without permissions. And so, we've done a lot on ponds. We have tested this out thoroughly on Homeowner Pond, pond up in Utqiagvik, Alaska, where we had permissions and worked with the native corporation up there to help us out and co-lead it and provide the permissions and all. And we have found that this works. This works really well. We use a safe material in widespread use, mainly for building application. With glacial ice, you've got people who are having really hard problems occurring, outburst floods, glacial lake outburst flooding can take down houses and infrastructure and hydropower and all that. And you have problems with your water supply. And so we were invited to work in the Himalayas. And that allows us then to really focus more on the adaptation effects of what can we do to make things work better so that the agriculture is more predictable, the water supply is more predictable, and the risks are less. And so that's our focus at Bright Ice Initiative. So it's the second nonprofit I've founded, and Bright Ice Initiative is we've already done some testing in Iceland with the Icelandic Meteorological Office, which looks promising, but looks also like there's more tailoring we need to do to now deal with slopes. And we are planning to do testing in both very small scale field tests still. We are planning to do testing in Iceland and in the Himalayas next year, the 2024. And that's a really neat thing. We're following processes recommended both by the Indian Ministry for the Environment and the AGU, American Geophysical Union, in the United States, which has updated its position statement on how do we test safely these small scale, how do we test these climate interventions that are proposed to do it in a safe way? And the secret is you certainly do it, well, it's no secret at all, but you do it transparently. You do it with co-leadership from people who live in the area. You collaborate on how it's done. You make sure you're helping with the actual challenges that they're facing, and you do it at a small scale to start with a lot of environmental impact assessment and a lot of water quality assessment as you go before you would dream of doing anything larger. So those are the, collaborating with the Icelandic Meteorological Office this year has been wonderful. And, we had all three layers of permissions that you could possibly get for this work on their second largest glacier. And we're still digesting the results of that. But it looks like we have a little more to go to be able to reliably and well keep things in place long enough to do the most amount of good in a sloped area. So that was a fairly long answer, but it's what we're up to. It's what we're doing.
That's that's wonderful. So you mentioned this is the second nonprofit, the first one being the Arctic Ice Project, AIP.
Yeah, it started out as Ice 911, which I really loved that name, uh, which embeds in it both a blessing and a curse, if you will. The Kurt Vonnegut story that Ice 9 came from, talked about what if we could keep things frozen. Was not, I don't think, even worrying about climate change, although he might have been. He was very farsighted, but it went too far. And so when you're doing some intervention or some treatment, you really want to make sure you're doing the right thing. So I loved that title. It became renamed Arctic Ice Project. And when we got invited to start working on glacial ice, I was more interested in that than AIP was at that point. And after a while said, I'll use my energy to do this new thing. And uh, I do like the idea that we could act as a catamaran rather than a couple of different, efforts there out there in the world. We could coordinate. So
And so the Arctic Ice Project is focusing on ice in the Arctic and bright ice on glaciers for now. That's like,
Well, it's not. I mean, yes, in the Arctic, but it's also mainly focused on sea ice at this point. Um, and permissions are hard to get on actually doing field testing on sea ice. So I'm delighted to be working in a realm where we can get permissions for field tests and work with local people to do it. Yeah.
w- w- what is like the main um, you know, reasoning behind the uh, permission difficulty?
But they cautioned that just international treaties take so long that it was, it was going to be a long time. And I haven't seen any signs that the international permissions are coming yet. So that's the real holdup. Whereas on a glacier, you have, you're land based and things you can test uphill, downhill, before and after, what you're doing. It's not, going to be diluted into an entire ocean. You're going to be able to do all the testing you need to on water quality and did it have any impact on anything. And so far the results are now coming back from a laboratory that we got to collaborate with in Iceland, and it's looking, as harmless as we hoped. So this is good. There's also testing on our materials that's going on still, funded by AIP's work now. Collaboration I had set up back when I was there with Sintef Ocean Norway, and they're really expert on these sorts of things too. To look at what are the marine impacts, if any. And so that's really nice. We keep looking over at that as much as they're publishing.
Would imagine you, you mentioned these silicon nanoparticles, SI. NPs, these hollow glass spheres, right? They're believed to be safe, and what does that mean, and how it it'd be difficult to test the marine biology effects. Imagine.
Well, I have to correct one thing. These are not nanoparticles. They are intentionally, we use things that are above 10 microns so that you're not going to have, respiratory effects. You're not going to have inhalation effects. And they are, yeah, hollow glass microspheres have been used in, there's a half dozen major manufacturers worldwide, I believe. One of which is going over to using some recycled materials to make them, which is great. That'll make the environmental impact of making them less. And they are, they're made of silica glass, and silica is one of the most abundant materials, in the world. It's in our rocks, our minerals, our oceans, our rivers. It's there. It's something we all evolved with. The nice thing about silica glass is that glass becomes amorphous, meaning that it is really harmless shapes. It's things that do not cause harm to people. So that's good. But going ahead to then, well, is any sort of marine creature going to have any effect from this? What is the fate of these materials over time? It's really nice having a scientific lab very well outfitted to do this, like Sintef Ocean.
When doing some research into silicon dioxide online, and and um, it like research online suggests these particles can be cytotoxic and induce cell death.
There are forms of particles, especially if you're going probably nano and below 10 micron sort of things. Um, there are shapes that can give asbestosis-like responses, right? If you have a needle-like shape. The thing about glass is that you melt that into round shapes. It's a amorphous. You don't get jagged needle-like things there.
So, so SiO2 has a water solubility of 0.12 grams per liter, and I think some of the research, maybe from you or others, suggests it dissolves within 6 to 9 months. Um,
Yeah, that seems to be that seems to line up with what we've seen in this pond, this homeowner's, well-lined Minnesota pond over the years. It depends on the pH. You can make things, I mean, depending where you are in the water, but we probably need to figure out one more piece of how to keep these things a little more stable if we want them to last for quite a while in the
yes,
environment.
the might imagine with the local wind gradient, the hydrophilic surfaces become important.
Yeah, the hydrophilic nature of the hollow glass microspheres that we've been using are really reassuring. That's what we have the most experience with so far, right? Anything else?
Yeah, I wanted to dive a bit deeper into uh, the materials
Mhm.
side, and what's going on in the atoms and these vibrations.
Hmm.
There's one wondering, do you think unbonded or bonded atoms m- um, would might be better at reflecting light and have a longer lifespan?
Not sure I understand the question. These materials, both these types of materials, the clays and uh, the silica glass based, are very reflective and they're granular. Perhaps you're going back to most people when they think about trying to preserve ice or snow reflectivity will go immediately to sheets, and I did too. But that's very hard way to go. And what I found, I got initially permission to work on a pond up in California, a few hours drive away from here. and where they had enough snow. And what I found was that as the melt starts, which is when you really want to have your most protection if you can, any kind of sheet starts having melting coming in from the edges, and any wind then goes and displaces the sheet, even if it's a hydrophilic sheet. You know, I had hydrophilic aspects to it, but maybe it wasn't completely hydrophilic, and so they'd blow away. And that's just a mess. It's impractical. It means that any sort of anchoring is going to be horribly expensive, and it's going to just make a mess. It doesn't stay where you put it, and
No,
that's useless. So I
it's
then started
for me.
wondering what granular materials, maybe that's where you're getting to, what granular materials could I use that could have the same effect? And that's when I started looking at I thought about those beautiful gift things I used to find in gift shops in Maine, for instance. Japanese fishing floats are just beautiful, and they're round glass, and it's like, wow, like that, but I want something smaller and white, and that's how I found hollow glass microspheres. And those are a much more practical, much more affordable, et cetera, type of material you could use. Maybe that answers the question you were asking.
Yeah, I think um I've come to understanding that the like sheet approach and specifically like a mirror tarp or PMMAs, I think it could be a affordable and easily anchored. I think it's worth considering more.
Oh, I've tried a lot along those lines. I have. The Swiss, I think, right now are using rubbery, thick, heavy sheets. That's the best they've managed to come up with at this point. And I wonder what that does to the environment around there while they're on. I mean, certainly that's far from a natural environment at that point. But I guess it does preserve the snow. So that's what they're after, the snow and ice. Um, yeah, I mean, I've tried a lot of sheets. My colleagues have as well. Um, but yeah, new ideas or new old ideas are always welcome. You think you've learned the complete answer, and maybe you haven't tried everything you could. Yeah, and I'm hoping for that, because that's something that could really solve, some of the really dire problems we have now from these positive feedback loops where the melt is accelerating, the oceans are warming. It's just it's one of these exponential situations, where it's not only getting worse, but it's getting worse faster and faster. That's what that means. So yeah,
Yeah.
it's an urgent situation. Yeah,
Yeah, I think um, it, on the environmental like saving side, it's kind of can be hard to feel that here on the land and surface that this is urgent. Um,
it's very urgent, and at this point, things have gone on long enough that I'm learning to get it in my gut too, that the best we can do may be to give people more time to adapt, more ways to adapt. Um, at this point, we are on that exponential curve, and if we can slow the acceleration of the exponential curve, we're doing a lot. It's unlikely anytime soon to get back to anything like 1960 conditions or whatever, right? So it's a dire situation, and it's getting worse.
I think uh, highlights how important yours and the team's research and work is. I think
Yeah, I mean, I'm working on this because it's urgent. Yeah.
some of the statistics we've came across is that on the Arctic ice side that you could help preserve a significant amount, up to 50 centimeters in the Arctic and 20% across large parts of the Central Arctic.
Right, the climate modelers that I've been working with for years that are now carrying it on, at Arctic Ice Project, are coming up with results that are showing that you can slow things down by preserving, and the areas that we had, the Climeformatics climate modelers Subarna and Dedalina and I had been looking at, advised by real polar experts like Peter Wadhams. So the Beaufort Gyre and the Fram Strait, those are strategic areas, and that was the main thing I was asking the climate modelers was, are there specific strategic areas that would have the most impact? Because you don't want to treat more than you have to, right? And that looks like it's coming out very well. They gave a very powerful poster presentations for the very. I'm sorry, I just got some weird message here. Uh, but some very large positive impacts of being able to do this in the right areas. And I'm asking similar questions. We'll be asking similar questions on glacial ice. What are the strategic spots? Where would it be the most help for people in their adaptation, people reducing risks? Um, as Yay, it took a while.
Yeah, there yeah, with 15 million people globally at risk near glaciers, I think your work and the Bright Ice initiative becomes ever more important. So,
Yeah, it's important work for sure. Yeah, thank you for highlighting us in this way. It is important to get the word out, and you're right, it's hard for people to drink it in. I've been reading more and more that it's really hard for people, unless they happen to be lifelong scientists, but it's hard for people to drink in the impact of what an exponential rise is all about. Which is basically what a positive feedback loop is all about. That is, that the more it happens, the faster it keeps happening, and it's not just getting faster, it's accelerating how fast it gets faster, right? And that's just hard to visualize.
and I think it's like really a function of asking ourselves each day, hey, uh, you know, how much dying marine life and animals do we continue to, damage and then feeling those emotions and feeling their emotions and the coral and all the ecosystems.
Yeah, I think most of us who are doing this kind of work, you know, really diligently, really full out, are doing it out of love for what we've got here and what we can't afford to lose, right? Because even if you're just looking at it from an investment standpoint, for instance, you know, those those trillions of dollars of economic losses, should be important. But the loss of the biodiversity on the planet that has been sustaining us all this time, has been tuned by evolution over all this time, is supporting us. It's the only place we know of that does that, right? And so far, and it's just so incredibly important to preserve it. And then beyond that, I mean, I'm looking out the window here and there while I'm gathering my thoughts at these various points, and it's like there's so much to love out there. It's all that life. This is what we've all grown up with, what what we cherish. And gosh, why wouldn't we do our utmost to preserve that?
Yes, we'll have to keep this in mind. I think it's beautiful, and I, we look forward to supporting your work and also mention including how to support an inscription and to support Bright Ice and AIP. And
Well, thank you very much for finding us and for for your support. Yeah, Bright Ice is brighticeinitiative.org. And I post some other things on LinkedIn, so you can find that from Leslie Field as well. And AIP, is still working away. And yeah, it's all important work. It's very important work. Thank you. Thank you. Same to you. Yeah. Thanks a lot. Take care. Thank you for listening, those who are doing that. Yeah. Thank you, Cole. Take care. Pleasure to meet you.